Welcome to the deep dive. We're diving into some really cool AI research today. That ROICtrl stuff you've been looking at. Getting AI to make pictures from words, that's one thing, but having it nail exactly what you want in those more complex images, that's a whole other challenge.
Yeah, you hit the nail on the head. ROICtrl is all about tackling that, making those AI images really match what you have in mind.
Makes sense. We've all seen those fun examples online, right? Like trying to get the AI to make a grid, each square with a different dog breed, and it ends up being a total jumble, breeds all over the place, maybe even a muffin or two thrown in.
Right. The Chihuahua or muffin problem. It's a classic example, actually. Figure 1 in the research shows it. And, even the really good models out there, even Dell E3 can trip up on that. So the big idea behind ROICtrl, and they talk about this in section 3.1, it's about giving the AI more to work with, not just words, but more specific instructions.
I see. So instead of just words, we're giving it visual cues too, like using bounding boxes for each thing we want in the image.
You got it. The paper calls this regional instance control, guiding the AI with both words and those visual cues. Text and bounding boxes together, it's like giving the AI a shopping list, but with pictures next to each item. Helps it get a much better understanding of what we want.
Interesting. It's like we're giving it more tools in its toolbox. I'm curious, how does this ROICtrl build on what's already out there?
Good question. They actually refine two main approaches for adding in this regional information, and they break it down in section 3.2. The first is implicit ROI injection, where it tries to use just text embeddings to say where things should go, but that can get really messy, like trying to describe how to arrange furniture in a room just with words.
Oh yeah, I can see how that would be a problem.
Exactly. And the other approach, explicit ROI injection, that uses attention masks, kind of like stencils to block off certain regions.
Yeah.
Better, but it can be a real resource hog, like using a huge paintbrush for tiny details.
So ROICtrl is trying to get the best of both worlds. Accuracy, but without being too computationally expensive.
Exactly. And their secret weapon is something called ROI-Unpool. This innovation, they explain it really well in section 3.3. It's inspired by a technique used in object detection, ROI-Align. Think about cropping a photo to focus on just one person, but then needing to put that cropped part back into the original picture perfectly. That's what ROI-Unpool does, but for AI image generation. It extracts information about each object, processes it, then puts it all back together seamlessly without wasting a lot of effort.
Clever. So how does it all come together? How does ROICtrl actually work?
Imagine an orchestra. The AI is the orchestra, right? And ROICtrl is the conductor. It takes the overall scene description, then adds these separate instruction pathways for each object. You can see this visually in figure 4. The AI already knows how to understand both text and boxes, so...
It's using what it already knows, but organizing it better.
Right. Like a conductor, ROICtrl blends these instructions to create the final image.
I see. The research mentioned something about using the MS-CoSEO dataset for training. Can you remind me what that is?
Sure. MS-CoCo, it's this huge collection of images, thousands and thousands, all with labeled objects. Section 4.1 talks about this. During training, you feed ROICtrl these images, along with their bounding boxes and text descriptions. That way, the AI learns to connect the visual elements with the instructions.
And the research also highlighted how flexible ROICtrl is, that it can work with different AI add-ons and pre-trained models.
Absolutely. One of the cool things about ROICtrl is its compatibility. You can swap out different pre-trained models, which means you have a lot of control over the final image's style, like choosing different artistic approaches. They touch on this in section 4.2.
So it's not just about generating images, it's about generating images with a specific look and feel.
Right. And then there are the add-ons, like ControlNet for fine-tuning positions. Let's say you want to adjust the pose of an object, ControlNet can help you do that. Or ED-LoRA, which gives you more control over how individual objects look.
Wow, so you can really customize things. I also saw something about continuous generation. Is that what I think it is? Like being able to tweak an existing image without starting over.
Yeah, you're on the right track. They touch on this in section 4.3. Continuous generation means you could, say, change the color of an object or add a new element without having to regenerate the entire image. It's still early days, but the potential is huge.
Sounds like ROICtrl has been put through its paces. They even developed a whole new benchmark for testing it, right?
They did. They realized the existing benchmarks didn't really reflect how people would use this tech in the real world.
And that's where ROICtrl Bench comes in.
Yep. Previous tests mostly focused on those template-based captions, just simple labels. ROICtrl Bench, section 5.1, goes into detail. It's designed to handle both those template-based captions and free-form descriptions, the kind of natural language we actually use. And the results. ROICtrl blew the competition out of the water, both in accuracy and efficiency.
Impressive. I think we've covered a lot of ground already.
Yeah.
Be a good place to pause before we get into the nitty-gritty of those results.
Sounds good to me. We've laid a good foundation for understanding what ROICtrl is and what it can do. In the next part, we can dive deeper into those benchmarks and see how it stacks up against other methods.
Welcome back to our deep dive into ROIC, or part one. We got a good overview, but now I want to get into those impressive results you mentioned, especially how it did on that ROICtrl bench. What exactly is that benchmark measuring?
Okay, so section 5.1 dives into this, and they break down instance control into two main parts. First is spatial alignment, basically how well the AI put the objects where those bounding boxes told it to.
So, like, did it actually put the cat inside the cat box, not halfway out or something?
Right. And they use a metric called mean intersection over union, or MIOU. It basically measures the overlap between what the AI generated and those bounding boxes.
Higher score means better placement, I assume.
Exactly. Now, the second part, regional text alignment, that's
Yeah.
where it gets interesting. They actually use another AI, a powerful language model, Mini CPM v2.6. They take the generated image, crop it around each object, and feed those pieces, along with the text descriptions, into this model.
So it's like one AI is judging how well the other AI did.
A great way to put it. And the accuracy here is basically how well that visual content matches the text description. Higher accuracy means the AI really understood what you meant and put it in the image correctly.
Makes sense. They also compared ROICtrl to other methods, but on different benchmarks. InstiffBench and MIGBench. Why use those too? Section 5.2 mentions this, I think.
Good point. You see, while ROICtrl bench focuses on both those template-based captions and the more natural freeform descriptions, InstiffBench and MIGBench mainly use those more structured templates.
Ah, so more like fill in the blanks, whereas ROICtrl bench is closer to how we'd actually talk to the AI.
Exactly. But here's the thing. Even with those differences, ROICtrl did amazingly well on all of them. The researchers wanted to show that it's not just good at one type of instruction, it can handle a variety, which is super important.
Shows how robust it is, yeah. Can we get into specifics? Where did ROICtrl really shine compared to the competition?
One area is generating those tiny objects. Table 2b highlights this. A lot of methods struggle with that, like instance diffusion tended to put extra objects outside the bounding boxes, kind of messy. And some others, GLIGen and ManGC, they had trouble putting objects accurately inside the boxes.
But ROICtrl got it right.
Way better precision. And that's a big deal because real-world images are full of those little details, right?
Absolutely. It's not just about generating the big obvious things. What about those out-of-distribution captions? Describing something really unusual, not something the AI was specifically trained on.
Yeah, that's a real test of how well it generalizes. Figures 11, B, and C show some great examples. Some methods totally fell apart here. Either they missed those unique attributes completely, or they had what they call attribute leakage, like colors or textures from one object bleeding into another.
So if you ask for a red apple and a blue banana, you might end up with a purple mess.
Exactly. But ROICtrl, even with those oddball requests, it stayed much more faithful to the instructions. Really impressive robustness.
This makes me think about those AI add-ons again. I'm still kind of struggling to picture how those work in practice with ROICtrl.
Sure. Let's take ControlNet, back in section 4.2. Say you use ROICtrl to generate an image, a cat on a table, but you want to change the cat's pose, make it look more playful. ControlNet lets you give extra guidance, like a quick sketch of the pose you want.
Ah, so it's working alongside ROICtrl, taking that initial image and tweaking it.
Right, like starting with a rough draft and refining it. And ED-LoRA works similarly, but for appearance. Want that cat to be a specific breed or have a certain fur pattern, ED-LoRA can guide ROICtrl to make it happen.
Wow, the level of control you can have, really exciting.
It really highlights how versatile ROICtrl is. It's not just a one-trick pony, it's a platform for all sorts of image generation tasks.
As we wrap up part 2 here, what's the big takeaway about ROICtrl's performance, its capabilities?
I'd say it's not just about being accurate, it's that adaptability and efficiency. It's generating the right images, and doing it smartly, not wasting resources, and it's open to working with other tools. That combination really makes it a game changer in AI image generation.
Welcome back to the deep dive. We've spent the last 2 parts really digging into ROICtrl, how it works, what it can do, its strengths. But I imagine there are some challenges too, right? It can't be all perfect.
Yeah, you're right. ROICtrl is a big leap forward, don't get me wrong, but there are definitely some things they're still working on, areas for future research.
That's what I wanted to focus on in this last part, those limitations, and where ROIC trail could go from here. What kind of challenges are we talking about?
Well, one thing they point out, it's in section 5.4, ROICtrl can have a bit of trouble when you have those bounding boxes that overlap a lot. A and D, they have similar descriptions. Like imagine you're trying to generate an image of two identical cats, all cuddled up together.
I can see how that might be tricky.
Right. ROICtrl, the way it works now, it really focuses on those individual instructions for each object more than the overall scene description. So in those cases where things are super close together, it can get a little confused.
It's like those spot the difference puzzles. When things are too close, the differences get harder to see.
That's a good way to think about it. Figure 10 in the paper actually shows this happening. When those bounding boxes overlap a lot, the model needs to use the overall context, that global caption, to tell those instances apart. But right now, ROICtrl's blending mechanism, it can overemphasize those individual object descriptions, which makes things a bit unstable.
So it's finding that balance, right? Paying attention to each object, but also understanding how they fit together in the big picture.
Exactly. And the researchers, they know this is a limitation. They talk about exploring different ways to improve that learnable blending strategy, making it more adaptable, so it can shift its focus between those global and instance captions more smoothly.
Like teaching it to be more context-aware, knowing when to zoom in and when to zoom out.
That's it. And beyond that, there are other really cool directions for future research.
One thing that caught my eye was applying ROICtrl to videos. I know the research mentioned it briefly, but have they actually tried that?
Yeah, they actually did some initial experiments with a video generation model called VideoCrafter 2. It's in section 6.2. Figure 12 shows some of the results, and it looks promising. With some tweaks, ROICtrl can definitely be used to control those instances within a video.
But I bet videos come with their own set of challenges.
Oh, absolutely. It's one thing to get objects right in a single image, but with videos, you've got to think about how those objects move over time, how they interact.
And it all has to look natural, not jumpy or weird.
Right, that temporal consistency is key, making sure things transition smoothly between frames. That's a big hurdle.
Sounds like a lot of exciting work ahead. Any other directions you're particularly interested in?
Well, one thing they mentioned that I think is really cool, it's in section 6.1, is combining ROI-Unpool with these things called diffusion transformers. These transformer models, they've been doing amazing things in image generation.
So taking the best of both worlds.
Exactly. Bringing those two together could lead to even more precise control over how those instances are generated. It feels like we're just scratching the surface of what's possible with AI image generation.
It's been an incredible journey exploring this ROICtrl research with you. We've gone from the technical nitty-gritty to the big picture possibilities, even touched on some of the challenges ahead. I want to thank you for sharing your expertise and making this such an insightful deep dive. And to our listener, thanks for joining us. Be sure to check out the show notes for links to the full research paper and some cool visual examples. Who knows, maybe you'll be inspired to create the next big breakthrough in AI image generation.